Welcome back to the session. I hope for the online, my voice is clear for all of you. Can you please confirm in chat box whether I'm audible or not? Okay, so we can start now. In the last class where we stopped the session, quota is done, right? Okay. So in today's session, I'm gonna speak about volumes in Kubernetes. That is stateful and stateless applications. Okay. Let me go and set it up very quickly. T2 medium. Can anyone tell me what is the difference between stateful application versus stateless application? Like what is the difference between them? Stateful versus stateless. The name itself is indicating stateful versus stateless. Mobile system. Let me tell you a scenario. For example, you call to customer service. Okay. After calling to the customer service, you got a problem with your mobile. So you call it to the customer service. So in scenario number one, while explaining the problem that you have got for your mobile, your call has been cut off. Your call has been cut off. So again, you need to call them. This time, some other person will receive the call, and you need to tell everything from scratch or not, sir. That is scenario number one. In scenario number two, first time you have given the call. Of course, second time, after that call has been cutted. Again, after recalling them, now you need not to explain the point from the scratch. Correct or not? So in that case, which one is better? Scenario number one or scenario number two? Scenario number two. Why, sir? In scenario number two, we do not need to start anything from the scratch. Already whatever you left at last point, that is going to start from repeating. First one is called as stateless. Stateless means which doesn't have any information of your previous state. Stateful means which have the information of your, that is the best example to understand. Okay. For example, if I take you as example, while I'm explaining the class, you are trying to listen to the class, right? At the middle of the explanation, you will go somewhere in your dreams. Then again, after 2 minutes, sir, you are asking me to, sir, explain one more time. The stateful or stateless? Stateless. Again, scenario number two, I'm explaining you the class. You gone somewhere, but immediately came back. Now this time, do I need to explain one more time for you? That one is stateful. Now, are you stateless or stateful? Stateful, huh? Sure. So, taking edge. Let's see. If you are stateful, I gonna be very happy actually. Okay. One moderate is enough. Huh? No need of three moderates. Huh? Okay. Anyways, GitHub, Raham Sheikh, all setups. Ubuntu Minikube. SH Minikube.sh. Oh, wait. Avoid the mm. Ninja technique means the ability to handle a situation in a better way without failing. That is ninja technique. Okay. Do you use these techniques what's your name? I forgot your name by the way. Tapas, Tapas. I forgot your name actually. Do you use these techniques? When was the last time you used it? After some time you will tell me. Tell me you can tell me now. In your home, what you told? Mm. Uh, mm. Mm. Yes. Okay. So coming back to this topic here, I'm going to have the minikube cluster in front of me. So in this minikube cluster, now I'm going to create some pods and everything. Okay. But the thing here need to understand is, let me explain the concept. Here, I'm going to teach about the concept of PV and PVC. Which one? So let me go and explain in detail about what is PV and PVC in Kubernetes. You know, volumes in Docker, right? Same concept here we are going to deal. But this time in volumes, I'm going to attach the Kubernetes concept. Okay. Persistence means always available. Persistence means always available. Just like Raham sir guidance for all of you. Anytime it is available for you. Huh? So PVs are independent that they can exist even if nobody is using them. That means my guidance will be exist for all of you if none of you are using it. Still I'll guide you. Like that. Okay, just joking. So again, persistent means always available. So these are independent that nobody is existing. I mean like using it. For example, let me go and see. It is a pod actually. For this pod, I want to use a volume. Okay. This volume I'm going to call it as PV. Persistence volume. Which one? The meaning of persistence is nothing but always available. That means it is completely going to be available all the time itself. Okay. So in real time, once you create the cluster, our cluster admin will create the cluster. Either he can create dynamically or he can create manually. Anything he can choose to create it. Once PV got created, it can be bound to persistence volume client, which is request for the storage by a pod. That means if I explain on this diagrammatical way, it is going to be very, very easy for all of you to understand. You remember this concept? Which concept is that? 3 tier? Correct. Today's demo actually. Same concept. So, wait. It is my cluster. Inside my cluster, what I create, sir? Majorly, I will be going to create the pods. It is a mini cube now. Okay. So I'm going to create like a pod here. So in general, what happened, if this pod wants storage, just like how we give volumes to the containers, here also we are going to create a volume actually. What we are going to create? That volume is nothing but PV, persistence volume. Which volume, sir? And this persistence volume, I'm going to give to a pod itself. Let's take this as pod 1. Okay. So now what will happen, here this PV, I'm going to set as 20 GB of limit. I can give 20 GB. How much? 20. Now this pod can use 20 GB, 10 GB, 5 GB, anything is fine. But the major factor you need to understand is PV main purpose is to create the volume. But it will not directly give volume to pod itself. Why? Because if I want to give volume from PV to pod, I need to create one more attribute called PVC. What I'm going to create here? Hey, wait. I'm going to create here PVC. PVC stand for persistence volume climb. Persistence volume climb. That means if you want the volume, you cannot take it from PV. You need to go and ask PVC only. That PVC only will go and give it. For example, let's say you want 100 rupees. This is you. This is your mommy. Okay. And is your dad. You want 100 rupees. Directly are you going to ask dad? No. First of all, you are going to ask to mom. And from mom to dad. Dad will give 100 rupees to mom or not, sir? Again, mom will give to you. Same like our Docker concept, Docker architecture. Same way of explanation. There is nothing change actually. That's it. It all depends upon how you understand. If you think concept is difficult, that is going to be difficult. But if you think it is easy, it's going to be very easy. Okay. So now again, a pod requests a storage. Pod requests 1 GB of storage. How will it get the storage, sir? First of all, it will go to ask PVC. PVC will go and take the volume from PV. PV is nothing but total amount of volume available for the cluster. Who will create the cluster? Admin will create the cluster. At the same time, admin is responsible to create the PV actually. So these are the first 4 points. Again, persistence means always available. And here the second point meaning is PVs are independent. That means if the pod is using volume, it will exist. Even though this pod is not using the volume, again it will be existed. Okay. Next here, if you go and see, when a pod requests storage via PVC, Kubernetes will search for the suitable PV to satisfy the request. That means, for example, let's go and see. For example, I'm telling, sir, I'm going to create one more PV here. I'm going to create one more PV. This PV will have only 10 GB. How much? 10 GB. Again, I'm going to create one more pod here. I'm going to copy paste it. I mean, like one more PV I'm going to create. But again, now this PV is going to have 5 GB only. This is going to have 10 GB. Wait, this PV have. It is also PV3. Let's take it is PV3. PV3 is having 10 gigs of data. 10 gigs stand for 10 GB in general. Wait. And PV2 is going to have 5 gigs of data, for example. How many gigs? 5 gigs. So now pod request 5 GB of data. How much? Now PV can take volume from, PVC can take volume from this PV2, PV1, PV3. Anyone it can take. But if the pod required 10 GB, it can only take volume from PV1 and PV3. No, sir, if pod required volume of 20 GB, it can take in PV1 only. So remember how much of data you are requesting. Based upon that only we are going to select the PV. But in real time, we create only one PV. Only for that one PV, we can give 20 GB, 30 GB, 40, 50, 60, we can give. How much you want, we can give it. Like that. That is the meaning of this point. Once a pod requests storage via PVC, Kubernetes will search for the suitable PV to satisfy the request. Sir, for example, as per the above explanation, you said you have 3 PVs now. So for 5 GB, 10 GB, 20 GB is there. But unfortunately, my pod is asking now 30 GB. Unfortunately, my pod is asking now how much? In that case, what will happen? Kubernetes automatically create a PVC. Why? Because 30 GB do have request here. No, Kubernetes will provision a PVC instantly. Is a point clear for all of you? Yes. Online, is a point clear for all of you? What is PV and what is PVC? Can you please confirm in chat box? So if somebody asks you in interview, what is PV? PV is total amount of storage available for the cluster. PVC is nothing but it will request the data from PV and it is going to distribute the data to the pods itself. That is a simple meaning. Okay. Here that is the last point. For example, if there is no suitable PV file, Kubernetes will either dynamically create a new one or PVC will remain unbound. That means either it can create a new one or neither it is going to unbound it like that. That is PV. And coming to PVC, to use PV, we need to claim the volume using PVC. PVC requests a PV with desired specification. That means you can specify the size, access, mode, speed, everything you can request actually. Okay. After bounding is done to pod, you can mount it to a volume. That means initially pod is requesting the volume. From where, sir? PVC. PVC will go and search for the PV. Once PV is attached to PVC, this PVC will give volume to the pod itself. Now this pod can use it. For example, if pod done with its work, pod no more want to use data, it can send back the data actually. That means we can decouple both PV as well as a pod actually. This is also possible. Okay. See here, that is the point actually. Once user finished, wait. One user finished its work, attached PV can be released. The underlying PV can reclaim and recycle for further purpose. That means if this pod is done with its work, it can release the PV. That PV can be usable for the future purposes. Which purposes? Like that. So simply one meaning. PV means total amount of storage available for the cluster, which is created by admin. PVC is nothing but taking the volume from PV and give it to the pods itself. And again, what is the meaning of stateful and stateless? Stateful means which stores data. Stateless means which doesn't store previous data. I need to use the word previous here. Previous. Okay. PV will store the previous data. PVC will not store the previous data. What is the best example? Call center example. Correct or not, sir? This definitely you might face at least once while calling to Swiggy, Zomato, and Amazon. Correct or not? Yes. So now let's go and create a PV. So here we have restrictions actually. Restriction is first of all, instance must be same availability zone as the currently. Where is my EC2 got located? In which availability zone? Not region, availability zone. AP South. That means you need to create it from EBS volume only. Okay. You need to create EBS volume from AP South 1A itself. Second one, EBS support only single EC2 instance mounting. Basically, I need to tell one small point for all of you. Here, whenever if we talk about PV and PVC, guys, in Kubernetes, we have a lot of volume types. First one is host path. First one is what? Second one is directory. Third one will be mounting. And last one will be this PV and PVC. Let me go through official documentation and explain what are the limitations. So if I type here volumes in Kubernetes, you'll be getting us 4 types majorly. Of course, 5th type is also there, but we don't use. See. Wait. Are you seeing host path? Host path means in our cluster, we are going to create a folder. In that folder, we are going to put the data, but this is not recommended. Why? Because if something happened to that folder, you can lose the entire data. Correct or not, sir? Is it a safer way to put data on our local path? No, that is the reason. This is not exactly we are going to use. Second one is going to be your after host path. Where it is the second one? Wait, let me go here. Better one. MTDIR. Which one? MTDIR is nothing but an MTDIR volume is created when Kubernetes is assigned a pod to a node. But the lifespan of the volume tied to pod is going to existing on the specific node. So MTDIR volume recreates when container restart or crash. However, the data in the volume is, that means is MTDIR good for you? No, host path is wasted. MTDIR is also going to be wasted. So these are the 2 different things which we are not going to use. Of course, config map is some other thing which you are going to see in upcoming classes. Don't worry it as of now. And we have something called as CSI as well as NFS. NFS stands for Network File System. I think in Linux you might heard about this word, right? The NFS concept done for Linux? NFS stand for network file system. Even though we can be able to put our data in our file system also. But apart from all of them, I choose cloud actually. Why? Because let me tell you it an easiest way. Sir, for example, if you put data on host path, that means in your like Kubernetes host, you are going to select a folder. Inside this folder, you are going to put the data actually. Unfortunately, something happened to this folder or something happened to this cluster. Entire data will be lost or not, sir? That is the first one. Second one, MTDR. MTDR will not store data permanently. MTDR is gonna store data in temporary way. So if I want to store my data in temporary purpose, I can use it. But permanently, can we use it? No, that is also going to be one of the worst method. Third one is going to be network file system. So network file system is somewhat of better when compared to this one. But I'm gonna use the advanced method that is from the cloud actually. That means if I want to store data of the pods, I'm going to create an EBS volume in the cloud actually. I think all of you know EBS volume, right? Here that EBS volume I'm gonna create on the cloud. And this EBS volume I'm gonna attach to my cluster, that is PV actually. Whatever PV I'm telling you here, that PV come from the AWS EBS volume. Which volume? Now tell me one thing. If you are using volume from the cloud, first of all, it will not delete. Even though it will delete, we can be able to get the copy of that EBS volume by using snapshots. In AWS, we have a concept called snapshot. Anyone knows about snapshot? Snapshot is nothing but backup of your EBS volume. So in cloud, if the EBS volume got deleted, unfortunately, again, we can get the backup, but rest of the methods, we don't have backup actually. That is the reason I'm selecting EBS as my top priority for using PV actually. Now tell me, for the cluster, where does my PV come from? From EBS volume. So that EBS volume I'm going to use as a PV. Let's go and create a EBS volume in your AWS instance. So go to volumes and you need to make sure that you are using the volume from the AP South 1A. Why? Because where is our server? So definitely need to create volume from AP South 1A only. Okay. I am taking size of 10 GB or you can take 20 also. That's completely fine. Availability zone AP South 1A. That's it. I'm not doing anything. So I just create a 20 GB of EBS volume and you can give the name also. For example, it is your volume. Like go for actions. Wait, let me give the name, proper name for it. If you want to see when it got created, you can go and check the creation time. Creation time, it just got created now, 1652. So this volume I'm going to give it as my PV. Which one? Okay, sir. After creating this volume, EBS volume, how you are going to convert this into Kubernetes PV? Means we have a manifest file. Go and write VAM PV. Okay. You need to copy paste this content and I'm going to explain this all of for you. First of all, API version is, how can I get API version? Kubectl API resources. Kind of what I'm going to create. Persistence volume, metadata. I'm going to give my PV. In the specifications, I'm going to give the capacity. So here I'm going to give storage of 10 GB, but I have created 20 GB now. So I can take this complete 20 GB also. Okay. So access mode, I'm going to give read write one access mode. Read write one means there is access mode actually where you can use this pod to read write one for the pods actually. Coming to elastic block storage, I'm using the elastic block storage as my PV. But what is the volume ID here? If you want to get the volume ID, you can go here and you can get the ID. This is the volume ID, okay? You can go and you can replace this old volume. And the file system type is going to be ext4, sir. What is the file system type? So if you are using AWS volume, by default, you are going to put the file system type of EST4. That is a default one which we are going to use actually. But if you are using Linux system, you can put NFS. What you can put? Network file system like that. So if I go and give kubectl create -f pv.yml. Now you got the PV. Name of the PV is gonna be my PV and kubectl get PV shortcut. So if you go in, see, are you getting the information of PV or not, sir? What is the name of the PV? Capacity Access, read, write. One. So reclaim policy, retain. That means if I want to reuse, I can be able to reuse actually. I can retain that once the pod finished its work. Status is available. Volume attribute, it is unset actually. If I want to get some additional information, kubectl PV, my PV. Are you getting the additional information now? Fine. See, it is telling that I am getting this volume. Source I am getting from where, sir? I am getting from Elastic Block. It is telling that it's a persistent disk resource in the AWS itself. Correct. Now clear the screen. So I have the PV now. I have the PV. So if I want to give this data, the storage to my pod, can I able to directly give it to the pod? No. What we need to create? PVC. Now write a manifest file for PVC. vim pvc.yml. I'm gonna create a new file. Here I'm going to put. So API version is v1, kind, persistence, volume, claim, metadata. Name of the PV is gonna be. Specification I'm gonna give access mode read write once. So resources I'm requesting the storage of 10 GB. That means my PVC is having how much of storage? But PV is having 20 GB, but PV is requesting how much, sir? 10 GB of data. How much? As of now, I'm taking 10 GB, but in future, if I want to increase the 10 GB, I can be able to increase it. It's up to my choice to increase or not. Okay, I'm gonna take 10 gigs of data. So after getting the volume from PV to PVC, can we able to give it to pod now? Yes, but before that, go and create the PVC. PVC.yml. Now the PVC got created. You kubectl get PVC. Are you getting the PVC now? So it is the PVC. Status is bounded. Bounded means our PVC is connected to the PV here. If it is unbounded, that means not connected actually. You can see the volume ID, PVC ID, capacity 10 gigs I am taking. Access mode, it is going for read write. So standard class is going to be what we are going to choose here, and age is going to be 7 seconds. Now you have the PV and PVC, right? Is PVC connected to my PV or not, sir? That means my PVC can take data from PV or not? Now after taking the storage from PV, now PVC will give it to pod. Now let's go and try out this one. So I'm going to create a pod here. I'll create replica set. So if you go and check out this one, the deployment manifest, which we are generally using now. Here everything you know, nothing new, but the only part is last part. Okay. So it is a deployment process. From here, I'm going to explain the things now. Here I'm using command actually. What I'm using? What is the command here? That means in the bash shell, I'm executing a command. Which command I'm executing? Sleep 10,000. That means see, if you are creating a container, inside this container, if you want to execute a command, you can write here as command. So with the help of bin bash from this shell, I am going to execute a command. That command is sleep 10,000. After that, here we are going for volume. Sir, you are getting the PV, but where you are getting the PV from? From my PV. Already I created PV. That PV name is gonna be my PV. And mount path means to which path of your container you are going to store data. See, currently you are creating container. Inside the container, in which path you are going to put the data. I am going to put the data on TMP persistent. And coming to the volumes, what is the name of the PV I am using? My PV. And I am claiming the volume from persistence volume claim called my PVC. That means from my PV, I am giving the volume. That volume is gonna take by persistence volume claim, and the name of the volume persistence volume claim is gonna be my PVC. The moment if I execute this one now, inside this path, if I go and store data, that is going to be kept forever. Let me show it practically for you. Kubectl create -f deployment.yml. Now it got created. Now give the command kubectl get pivot. Now the pod is going to create. So let's go and execute a command inside that container. So the command is kubectl exec -it name of the pod hyphen hyphen slash bin slash bash. If you go inside, I am into the shell now. What is the path I have given? TMP. Inside TMP, are you seeing persistent? Go to this path cd slash TMP persistence. Create some files. Touch raham 1.5 and give the command cat greater than raham1. This is wait guys. This is my file 1 from my PV from container 1. I'm writing some data. I'm gonna save it now. I have the files and I have the data inside the file. Now I'll come out of it. Currently tell me one thing. How many pods you are having now? How many pods? One pod. Inside this pod I put the data. Where I put the data inside this pod? In the folder of TMP persistent. Correct or not, sir? This is the path. Now what will happen, even though if I delete this pod will recreate. Why? Because we are using what here? We are using deployment. What we are using? The moment if I recreate the pod, automatically new pod will come with a different name, but in the same folder, you are going to get the same data. Let's go and verify. kubectl delete pod name. Is the pod deleting now? How it will be recreated? Why? Because we are having deployment. So deployment can have replicas. Replicas can able to recreate the pod itself. Correct or not, sir? Yes. So now if you go and see, kubectl get PO. Have you got the new pod now? Is it running? Now go and check kubectl exec hyphen IT, name of the pod, hyphen hyphen. If I give hyphen hyphen, it will not give you anything. Definitely we are going to provide bin bash. So you will go to the bash shell. Wait, SH is missing. Now if I go cd slash tmp persistent, if I give ls or ll, are you getting same files now? Cat file 1. I mean, sorry, cat raham 1. Are you getting the same content now? Again, I will go back and again I'm going to delete this pod actually. So now again the pod is going to recreate or not, sir? Yes. So kubectl delete pod and name of the pod. I'm deleting this pod. Eventually new pod will create, right? But for the new pod, will I get the same data in the same directory? Yes or not? Yes, that is a functionality of PV and PVC. That is called as stateful. Stateful means your previous information will be stored. Is it stateful or not, sir? Let's go and verify one more time. kubectl kubectl get PO. So now kubectl exec. Tell me the command. IT. The pod. See what is the best thing, from here also you can execute the command ls slash tmp persistent. No need to go to the bash shell. From here also you can execute the commands. Are you able to see the like files now? And even you can get the content of the file. For example, go for raham1 and put the cat command now. Which command? Are you seeing content now? If you put bin bash here, you will be going to bash shell. That means you can go inside the container and you can run the commands. But you don't want to go inside the container. You want to execute the command from outside. After hyphen hyphen, execute whatever the command you want. So now if you go and see the diagram here completely, these pods are getting the storage. And if one pod got deleted, second pod is getting the same data. How means here in the manifest file, I mentioned every pod need to get volume from same PV and same PVC. Already when the volume is allocated, whatever the data you are going to store, the data will store on the PV actually. Where is PV now? In the EBS. Even though if my entire cluster got deleted, for example, let's say if my cluster got deleted, I have this EBS volume inside the cloud or not, sir? I can create the new cluster and I can use the EBS volume now. So this is how exactly the concept of PV and PVC is going to work in the real time. And this is what you are going to call as stateful and stateless application. Now is the concept of stateful and stateless clear for all of you know? Online, can you please confirm me? Is the concept of stateful and stateless clear for all of you or not? Okay, fine. So this is the whole and soul concept. But to understand this PV and PVC, a lot of people will feel difficult, but it is not difficult actually. The only thing is proper structure you need to understand from PV to PVC, from PVC to pod, PV to PVC and PVC to where is PV now? In the cloud EBS. Why not in the local? It's not a safer path. In local, if you deleted anything and entirely you are going to lost it. Okay. And one of the common thing here you are going to understand is, sir, in Docker also we learn the volumes. In Kubernetes also we learn the volumes. Correct or not, sir? But are we going to use the Docker concept means? No. Why? Because ultimately at the end of the day, you are going to choose Kubernetes over Docker. So Docker volumes is not necessary. You need to focus on Kubernetes volume. But if your company is using Docker Swarm, then Docker volumes are required. Is the logic clear for all of you? Ultimately, what I can say is Docker is the tool that to create images only. Apart from that images, you don't do anything. That's for damn sure. Fine. So the next concept is gonna be multi-container pods in the Kubernetes. Generally, till now, how many containers you do have on the pod? How many containers? But let me show you how to create multi-container pods in the real time. It is very easy, but before that, let me go and delete the existing resources. So I removed everything here. You know the basic manifest file of pod, right? Can you tell me the basic manifest file of pod? Sure. Huh? Yes or no? देखेंगे. VM pod.yml. Tell me the four mandatory fields. API version v1. In kind case, capital or small? Correct. Kind pod. Hmm. Name is nothing but multi-container pod I'm giving. Multi. That's it. Even if you want to add container 3, name, container 3, image, can take any image. Before I go and create this one, Previously, if you go and say, are you seeing one by one here? I'll tell what is one by one there, okay? kubectl create -f pod.yml. kubectl get PO. Are you getting 0/3 now? /3 indicates number of containers. What it indicates? Yes. If you go and see 0/3. So still these are creating. Wait for some time, okay? It will take some time to create. So currently container 1 got created, right? Container 2 and 3 is on crash loop back off. I want to check what is the reason. I can go for kubectl get events. If you go and see, it got failed. Image size is so and so bytes. Okay. It is telling that image size is not good. Okay, let me do like with the base image actually. Of course, you can do that image also, but let me go with basic image. VM pod.yml. First of all, give me the command kubectl delete -f pod.yml. I'm removing them. I'm giving some basic image names like Nginx and everything I'm gonna give. I mean, these kind of questions you will get for the experienced people, but fresher, it is better to have what is multi-container and what is the use case of it. Okay. VM pod.yml. So I'll gonna take the image of, I'll take some other image called Nginx. Nginx latest. And this one I'm gonna take it as CentOS. Image name can be anything, guys. No need to worry about this one. So these containers are on creating status. You can use kubectl get events. What is going to happen? In the events, if you go in the top, 2 seconds ago, multi-container got successfully pulled the image Nginx and successfully pulled the image CentOS. Both of them are pulled actually. So if you go in see again 1/2, what is the reason for it? One container is running out of two containers. So give the command kubectl describe pod and name of the pod, that is multi-container pod. So here it is telling that it got back off, restarting fail because other container one pod one multi-container is using that one. Why we are getting this image size in bytes? Basically this won't get. Okay, let me do one thing. Let me pull out the thing from the official documentation. Multi-container pods. Kubernetes. That need to come actually, but unfortunately it is not giving the output. Wait. You can see container Nginx I have taken. Okay. Second one is Ubuntu, but it is not giving me the proper output. It is, I think image is the issue. I think I'm getting the image size actually. Wait, let me go through ChatGPT. Guys, whatever we have given is correct only. The ultimately, like I'm getting some new issue that is called as size of the image. I don't know why it is getting. Okay. Generate a manifest file for multi-container pod itself. I've seen official documentation also, but let's check. If you go and see again the same manifest file, name and the image. Here also name and the Let me try with different images. I'll go and take with different image. I think this is not working as per my expectation. CubeCut will delete -f pod.yml. am pod.yml. Now I'll use this one. Okay. But for this one, like I don't want this container share data in, like I don't want everything here. Okay. I can remove all of this. Now see. CubeCut will create -f pod.yml. So I'm creating. Wait. When I'm getting crash loop back off. Getting this crash loop back of CubeCut will get events. In the event section, what it is telling to me. So exactly few seconds ago. Yeah. 1 second ago, it got container pulled. Okay. Multi-container pod, back off restarting fail. Container sidecar. Okay. Something is not wrong. Sorry, something is not right here. I need to check the issue. But okay, fine. Like, let me explain the patterns actually. Of course, tomorrow also we are going to see the multi-container pods. But here today, I'm going to explain the patterns first of all for you. So in the multi-container, first pattern is going to be sidecar actually. Which one? Sidecar. Sidecar is nothing but it is going to help the main container. For example, let's say I have a pod actually. It's going to be very craziest concept. I have a pod. Inside this pod, I'm going to have two containers. How many? Container number one. For example, if I have single container, let's say this single main like more load. That is the reason I'm going to create the container number two. So what is the functionality of this container number two? You know, it is going to be very easy. For example, if user is trying to log into the application, if I use single container, that single container need to check the login information and use the application. But if I use sidecar pattern, whenever user try to log into the application, first of all, container number one, check the user login information. If it is correct, it will serve the application. Or if it is not correct, it is not going to send the user to the application. That means with the help of second container, I can reduce the load of the first container or not, sir? This is what exactly we are going to call the sidecar pattern. Which one? Sidecar is nothing but the main container will have the application and the helper container will help the main container, just like logging process, checking the information and everything. That's it. Second one is going to be adapter designing pattern. Which one? Adapter designing pattern is nothing but it will standardize the output pattern of the main container. That means, for example, let's go again. I am having two containers here, container number one and container number two. Container number one gives some output to container number two. So this container number two is going to take the output and gives the output in a standard format actually. Which format? For example, again, user is trying to log into my application. Container number one take the user information and gives to container number two. But here container number two will create a specific pattern for it. Like that. Third one is going to be ambassador. Ambassador is nothing but user to connect the container to the outside of the world. That means, let's see here how many containers I have. Container number one and container number two. Let's say my container number one is having application. I don't want to expose the container number one to outside of the world. In that case, what I'll do, I'll give the application to container number two and I'll expose the application from the container number two to the outside of the world. This is what we can call as ambassador designing pattern. And final one is going to be the init container. Init container like itself is nothing but it will initialize the work and it is going to exit later. For example, let's say I have two containers. Container number one is going to have the application code. Container number two is going to run the application. One container number one gives the code to us. Do we need to use container number one more time? No, why? Because code we want only one time. After giving the code to us for the application, this container will be exit by itself. Now container number two use the code from the container number one and runs the application. So these are the 4 designing patterns which you are going to see in the real time. So again, the concept is going to be multi-container pod. So multi-container pod means here inside the single pod, how many containers you are going to have? 2 or more than 2, anything is fine. Okay. So in the sidecar will help the main container. For example, if container number 2 is having the application, container number 1 will check the login information and send the user to the container number. So it is going to reduce some load actually. Second one is going to be adapter. Adapter means whatever the output given by container number 1, container number 2 will take the output. It is going to treat on a standard format actually. Third one is going to be ambassador. Instead of exposing the main container which is having the application, I am going to expose the dummy container to the outside of the world, and the application I can give from main container to the dummy container. So dummy container will go and expose to the world to give the application. Last one is going to be init container. That means how many containers I have here? 2. Container number 1 will give the code of my application. Container number 2 will take the code and run the application. Once code is given, do we need to use this container anymore? No, automatically it is going to terminate itself. So these are the 4 different patterns for the multi-container pods. For fresher, it is not required. But if you are experienced, definitely this question you are going to face on the interview. That's it. So this is the concept of today's class. In today's class, how many topics we have seen? 2. First one is going to be PV and PVC. Second one is multi-container pods. So PV, PVC main purpose is to give the storage for the cluster, and multi-container pod is nothing but whenever you have different requirements, based on the requirement you are going to create. Again, in real time, multi-container pods are not mandatory really, but if there is any specific requirement, then you can go and create them. That's it. So now, before going for doubts and queries, is the concept clear for all of you today? Everyone? Online, can you please confirm, is the concept clear for all of you or not? Can you please confirm in the chat box online? If it is clear, we can go for the doubts and queries part. Clear. Okay. So now I'm gonna give unmute option for the people who is having queries. So first of all, Shrivani, you can go ahead, Shrivani, with your query.
Hi, sir. Good morning. Sorry, good evening.
Okay, anything is fine. Okay.
Actually, the one which you are doing, PV, using PV,
Mm.
I tried with that same thing.
Okay.
Before giving the persistent volume claim,
Ah.
my container is, deployment, everything success, and the container is running fine. So after providing the PVC, the one which you have got it, the crash loop backup, same thing I got it. When I check the logs of that container,
Ah.
I have seen like the permission error. The actually mount path which I have given is their path. It's unable to copy.
Okay.
Permission denied, like that. How to
Okay.
solve that permission?
So don't worry, tomorrow I'm gonna show you Kubernetes GPT. I'm gonna take a separate class for troubleshooting. I'm gonna list out all the errors which you are going to get. Okay. So I'm gonna use Chat GPT and Kubernetes GPT for it, Shivani. So every error what you are going to face in real time, I'll take a separate class and I'll explain for you.
Okay.
As of now, you can just leave it off. Okay.
Okay.
Yeah. And one more thing, if you don't do the process in the correct way, it is gonna result on error only. So this thing you need to keep it off every time.
Okay. Okay. And
Yeah.
one more thing, the one we are trying to log in container with the root. Root access or
Yes, by default it'll go with root access, but if you want to restrict the root access, you can go and you can restrict. That is
how to
completely
do?
fine.
How to restrict? Where to, from where to?
Let me show you. Basically, if you go to the official documentation in the Docker itself, there is a process. Root access restriction for a Docker container. I mean, in Docker file itself, you can fix it actually. Okay.
Okay.
Like if you go and see Docker user restriction, it is official documentation of Docker. Here, if you go and see, are you seeing the current user ID?
Okay.
Okay. So like this, first of all, you need to mention which user you want to restrict actually and which user you want to allow. So like that, you are going to specify the user ID and group ID. From there, in the Docker file, you can run the command user add. So this is the command to add the user. And are you specifying the user called my user? Now
Okay.
the user called my user is going to run on the container. That means you can be only able to work with that user. You are not going to use the root user. So it is the way actually. Simply you can go and specify the username in the Docker file itself. I hope it is
It
clear for you now.
it has full access. How can you check it?
No, no, no. If I
That
want
same.
to provide the access, you need to go to vi sudo, right? Vi sudo file. See,
Okay.
simply in the Docker file, run the command user add. That is going to create the user. And next here in the user section, specify the username. Okay, if you
Okay.
do this one, automatically now Docker file will create this user and going to run on this user only. But if you want to put the restriction for that user, go to vi sudo and put the restriction as per your requirement. I think Linux bot I have shown this one in the class itself, starting beginning.
VI sudo from the container or how?
From the container actually.
Uh, okay.
Okay.
And one more thing, if you want to implement the LDAP
LDAP. Okay.
in this for the container LDAP access.
Basically, LDAP is not required. Here you are restricting user itself within the Docker file, right? So why to use LDAP?
No. Suppose our team has some users.
Hmm.
So instead of providing each user there,
Hmm.
can we implement LDAP?
It is not really that much of required, Shivan, if you ask me. Implementation of LDAP is not that much of required for this scenario, if you ask me.
But in real time, we need to provide the access using the LDAP only, right?
That's what I'm telling. See, create a Docker file. You have two users. One is root user. Second one is non-root user. Create a non-root user. Give some permission for him and ask every of the teammate to use this non-root user only. In that case, why to use multiple users actually? Within the single common user, you can be able to work with multiple people, right? But again, if
Yeah,
you want to specify multiple users also, you can specify it.
yeah. But if a team is having 40 members and all, it is very difficult to give it.
So in that case,
And
you can implement LDAP. Definitely you can implement LDAP.
how to do and all,
Yeah.
can you show us?
Basically that even I never used LDAP actually. We have some different mechanism for it, Shivani. But if you want, I'll send a document for you. You can go and refer through it.
Okay, sir. Thank you. That
Thank you.
helps.
Fine. So guys, any other queries from your end? What is that? That is the path actually. In that path, you are going to store the data actually. Okay. Tell me. Sorry. Okay, let me explain this one. Basically, it's a good question. Everyone forgot to ask, but you are asking fine. So the meaning of read write one indicate whether you are using it on single node or multi node. If you are using on single node, you can get read write once or you can get read write many. Let me explain that one. So if I go to official documentation, PV and PVC, read write. So directly you'll be going to the official documentation. In this, if you can go and see, at the end, you can see the description actually. Wait. The reason why I'm showing official documentation means official documentation will be giving lot of flexibility for you to understand more things actually. If you go read write once means the volume can be mounted as read write by a single node. If you give read only many, that means volume can be mounted as read only for many. If I put once, that is only for one node. If I put many, that indicates many node. And there is read write many. That means the volume can be mounted as read write by many nodes. And finally, read write once. That means the volume can be mounted as read write by using a single pod. So this is the information. Let me give it for your notes. So here I need to give. Yep. So I'm gonna give it in short and sweet manner. Read write many. Read write once. That means you are going to the volume can be mounted. Read write for only single node. Okay. Second one is going to be read write many. Read write many will be indicating the volume. The volume can be mounted as read write by many nodes. And next one is going to be read write many. That means the volume can be mounted as read write for many nodes. And read write one pod means only one pod is going to read and write. Is the concept clear for all of you know? Yes. The reason why I have take read write once only means I am using Minikube only. But if I use K-ops, I need to go for read write many. That's it. And these not on your new notes actually. I need to upload this one more time. Okay, fine. So in the meanwhile, any queries from you, online or offline? Persistence volume climb. C stand for climb actually. What is the meaning of climb? To take. Okay. Climb means climb, eh? Climb means to take actually. Okay. Rajesh, you can speak, Rajesh.
Hello, sir. I have a question.
Please go ahead.
Yeah. So we are creating EBS volume. Suppose let us assume EBS volume size is 20 GB. Can we create multiple PVs from the EBS volume? That means
basically one PV. If I create one PV, for that one PV, you can go and proceed with one PVC only.
So that means it is restricted to only one.
Yes.
Okay. So similarly, for one PV, can we create multiple PVCs or only it is restricted to one PVC?
See, one PV for one PVC only. In real time, we will do like that only.
Okay. Even though the PV size is 10 gig and we keep a PVC size 5 gig, it is only restricted to one.
Yes.
Okay.
Yep. Hope it is clear for you. Fine. So online, still any doubts or any queries from your end? So online, still any queries? Yep. No, it's not for you. It's for next batch. Huh? It started lately. But again, some of the topics you are going to cover. So KTS GPT, it's not on your syllabus, but I'm covering. CubeCost is not on your syllabus, but I'm going to cover. HCP is not on your syllabus, but I'm going to cover. Terraformer is not a part of your syllabus. It's not Terraform. Terraformer is different. That is also not a part of your syllabus, but I'm covering. Na? This is not for you. This is for separate batch. Okay. That is the reason I stopped the screen actually. Stop it first of all. Okay. So still any queries? Is advanced DevOps with AI. I'm going to integrate AI also. Sorry? Tools, free tools only, no paid tools. Course fee, same. Yeah. Mm. So guys, any doubts or any queries from your end? Mhm. By today we cover many. Today we haven't seen many topics. Only two topics. One is multi-content report. Second one is PV and PVC. All topics is not required, Vikram. It depends upon your requirement actually. Okay. If you learn some n number of topics, it doesn't need to use n number of topics actually. Tomorrow I'm gonna teach you config maps and secrets. Then after that, I'll show you the monitoring in the Kubernetes, how to monitor the cluster, how to optimize the cost, everything. I'll teach you. I already said I'm gonna give the overview of FinOps actually. Definitely, I'll teach you how to optimize the cost, how to check the cost, how to set the limits. Everything I'll teach you. Even though it's not a part of your syllabus, but for your knowledge, I'll definitely teach you. Okay. Yeah. Tell me. Sorry. Syllabus. हाँ. अभी न्यू सिलेबस क्रिएट कर रहा हूँ. Okay. It's not the existing one. So guys, any questions still if you are having, you can ask me. Okay, so then that's it, guys. If you are not having any doubts or any queries, we can wrap session for today and let me down tomorrow session. Have a great day. Bye. Thank you, everyone.